Examples of molding include extrusion, power metallurgy, thermoforming, and strength fitting. Rubber responds to the molding process in the following steps. The mold closes, a plasticizing screw rotates to force the injection of an accurate volume of pre-plasticized rubber compound into the mold. Material is directed into the mold via a system of runners to each individual cavity, each having small injection ports. Material is cured for a predetermined time during which the plasticizing screw retracts and plasticizes sufficient rubber for the next injection. Mold opens and parts are removed manually or automatically by robotic or other systems. This cycle is then repeated. The next manufacturing process of rubber is forming. Examples of forming include forging, rolling, extrusion, pressing, bending, and shearing. Rubber responds to the manufacturing process of forming by using a flexible material such as a rubber or polyurethane to form a sheet metal workpiece. Often the rubber is encased in a steel container and serves as a punch. A working piece is placed over a rigid die. The punch forces the work into the rubber. Rubber is forced all around the work, creating pressure and forming the metal onto the die. The third manufacturing process of rubber is joining. Examples of rubber joining include soldering, brazing, welding, fastening, induction, and adhesion. The slabs are machine cut or chopped into small pieces. Next, many manufacturers use a Banbury mixer invented in 1916 by Finley H. Banbury. This machine mixes the rubber with other ingredients. Challenges of this process begin when you begin to take sulfur and vulcanize it, pigments to color it, and other chemicals to increase or diminish the elasticity of the resulting rubber bands. The final manufacturing process of rubber is coating. Examples of coating include engraving, painting, and chemical vapor deposition. Production coating of fabric with celastic silicone rubber dispersions is usually carried out in a coating tower. Fabric is unrolled and fed continuously through the dispersion and a dip tank, then through a heated vertical tower for vulcanization and onto a take-up roll. Challenge in this process begins once the fabric is wetted. The fabric is wetted best when it enters the dispersion at an angle of about 45 degrees. At this angle, it is not so likely to trap air in its interstices.
In this next section, we will take a look at the problems associated with the manufacturing of rubber and the rubber industry as a whole. The first problem is deforestation. There have been many issues with the rubber industry concerning deforestation because rubber requires a specific tree in order for it to be harvested. The next problem concerning the rubber industry is sustainable agriculture and smallholder farms. The rubber industry has been known to usurp land from small landowners in order to create plantation space for its rubber products. This mainly happens in countries in Asia such as Laos and India. The next problem is one concerning sanitation and hygiene. Improperly disposed of piles of rubber can become breeding grounds for insects like mosquitoes that can carry diseases, as well as become breeding grounds for vermin such as rats and snakes. The last problem we're going to be looking at today involves landfills and environmental waste. If disposed of properly, rubber poses no threat to the environment. However, if improperly disposed of, it can cause problems. For example, improperly disposed of rubber piles can be lit on fire and burn toxic fumes. There are also problems in the rubber making process itself in terms of not knowing what to do with the chemical waste that is generated during the process itself. The last problem we're going to be looking at today involves landfills and environmental waste. If disposed of properly, rubber poses no threat to the environment. However, if disposed of improperly, it can cause problems. For example, an improperly disposed of pile of rubber could be lit on fire and burn toxic fumes. There are also issues during the rubber making process itself. These issues arise from not knowing what to do with the chemical waste that is generated during the process. The last point we would like to touch on today is what happens at the end of rubber's life cycle. Rubber can be recycled in one of three different ways. It can be refurbished, for example, retreading an old tire. It can be completely broken down and turned into something new, or it can be incinerated and used for electricity generation. However, as mentioned before, there can be issues with rubber being put in landfills. For example, in the pictures below, these used tires have been placed into a landfill and forgotten about, whereas they could have been used for recycling materials as stated before. The creation of these landfills can lead to some of the previously stated environmental effects. And that concludes our presentation on rubber. Thank you.